Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Rendy Elang Lesmana. I am from Informatics Engineering Study Program from Ti23i. In this video, I will presentation about data structure and algorithm. So in this video, we're gonna talk about the first is introduction, why I'm making this video, what the purpose of this video, and then the second we will talking about the algorithm. I will explain about algorithm and their types, and then third, I will explain about data structure, explanation about data structure and their types, and the last session we will do coding practice, live coding practice using Python. So I hope you can enjoy of this video. So introduction, the purpose of this video. So the purpose of this video is to complete essay question on mid exam. So I hope I can get a high score from this video. So I will explain about algorithm. What is an algorithm? So algorithm, informally, an algorithm is nothing but a mention of steps to solve a problem. They are essentially solutions. In computer programming terms, an algorithm is a set of well-defined instructions to solve a particular problem. It takes a set of inputs and produce the decides. So it's all about solving a problem. And then there are several types of algorithm. There are several ways to solve a problem. As you can see, the first is description, and then flowchart and pseudocode. We will dive into this point. So, what is description algorithm? Description algorithm is look like this. As you can see, it's pure human language, right? So we have problem here. We let's say we have problem. We want to make some noodle. So uh, to solve that problem, uh, we have to describe step by step of uh, for solving that problem. As you can see here, description: cooking instant fried noodles. From the first step is pour enough water into the pot, turn on the stove, put the pot on the stove, and etc. As you can see, if we uh, if we declare description, this must be in sequence from the first step into the last step. It have to be the sequence, right? And then we will move into the flowchart algorithm. So this is flowchart algorithm. As you can see, this is a basic symbol of flowchart. This is known as terminator, which means the start or the end of the program. And then this is arrow. Arrow is used to connect from the symbol into the other symbol. And then this is known as data, which means is input or output process. And this is process. This is pure of process. And the last is decisions. Decision to make conclusion like it. Like this, we have example making the tea from the start, and then we go to the next step, fill the kettle, and then heat water. And then here we have decisions. We have conditional here as the water boiled. If the water not boiled, so will does it will move into the previous step known as heat water, and then go to the next step, and this is check again as the water boiled, and if the condition is true, which means yes in here, and then we can go to the next step, is make tea and stop, like that. And the last types of algorithm is pseudocode algorithm. As you can see, Pseudocode is a way to write algorithms that resemble programming language with some conventions. As you can see here, is resemble of like programming language, but this is pure of human language. We declare variable here, we declare the data type here like integer, we declare here, and then we declare like functioning here. From the we declare the parameter here, like this is resemble like programming language, but this is pure uh, human language. That is it. So we're gonna move to the other topics is data structure. So what is data structure? A data structure is defined as a particular way of storing and organizing data in our devices to use the data efficiently and effectively. So remember, if you build some maybe application is will not go far from the data. You should you also always need to use data for your program. So this is data structure functioning like that. So there are several types of data structure. As you can see here, we will talk about queue data structure and then move into the stack data structure and then the linked list data structure. So the first is queue data structure. What is queue data structure? Uh, queue is a useful data structure in programming. It is similar to the ticket queue outside a cinema hall, where the first person entering the queue is the first person who gets the ticket. Queue follows the first in first out FIFO, which are known as FIFO rule. The item that goes in first is the item that comes out first. So the second is stack data structure. A stack is a linear data structure that follows the principle of last in first out. In the previous is queue is the first in first out, but in here stack data structure is last in first out. This means the last element inserted inside the stack, it will be removed first. Example, you can think of the data structure as the pile of plates, right? Like this, on the top of another. Here you can put a new plate on the top, or you can also remove the top plate. But as you can see, if you want to take bottom the the bottom plate here, you have to remove from the pile from the plate by plate from the top, right? So, and if you want the plate at the bottom, you must first remove all plates on top. This is exactly how the stack data structure works. And then the last is linked list data structure. So a linked list is a linear data structure that includes a series of connected nodes. Here, each node stores the data and the address of the next node. Example, as you can see here, this is exactly how the linked list looks like here. The first data is called known as head here, and then we have node here, and then the node is have to branch, maybe to branch, right? The first branch is data, and then this is link to connect to the other data right here, like this. And the last linked list is known as null, like this. You have to start somewhere. So we give the address of the first node as a special name called head, right? Also, the last node in the linked list can be identified because its next portions points to null, right? Linked list can be of multiple types, like singly, doubly, and serial linked list. Okay. Uh, we will do live coding using Python. Live coding using Python, we will doing like queue data structure using Python, stack data structure using Python and linked list using Python. So I hope you can understand. Okay, I'll try my best to build to make Q data structure here. Q data structure code example. So the first I will make some class, and I will name as class is Q. So I will make method here in self. Oh, sorry, I'm missing some steps here. From collection, import the queue. I will use the queue as queue data structure. Def in itself, and then self dot buffer equals to the queue. Okay, and then I will make method for add an element. Def, and then I will give queue as the name of method, and I will give parameter self here, and then the data parameter here. Okay, and then self dot buffer dot append left data. Okay, and then the next I will make a method for remove an element. Okay, I will make function here, and the name of function is what's that? The queue self return. No, not return, but yeah, return self buffer pop. Okay, right, and then I will take the length of the queue here. Def size self print length self buffer. Okay, all done. I will try to call the class. I will make some a variable here, maybe q like this. Then I will call the class. Okay, and then I will add an element to the queue. Oh no, maybe I will change the name of the variable to data, maybe data, and I will call the queue method here, and then maybe I will give my name as the value. I will add the other, I think one more, maybe like 0.9. Okay, so I will try to print the data. Run here. Okay, this is already into the queue, right? So as what I said before, queue is first in first out, which means the first element to be added to the queue will be the first element to be removed first, right? Let me prove. I will try to remove an element. I will call the queue method here. Okay, and then I will print the data again for the make sure if the data is already delete it. Okay, save and then run again. Okay, as you can see, right, the first element who be the first in will be the first element who be the remove first, right? First element, first in element, first out element, like here. So this is exactly how queue data structure works. Okay, I will move into the second data structure known as state data structure. Okay, I will make class again here, class state. Oh no, I forget to import the library from collection, import the queue. Okay, I will use the queue from for the stack also. So I will make function here, def init self, not self, self the buffer EQ. Okay, and then I will make a method for add an element. Def def you self no def add self data. Okay, and then self dot buffer dot append data, and then the last I will make function or method for remove an element. Okay, the remove self dot buffer dot pop. Okay, all done for the class stack, and I will try to make a new variable here known as maybe items equals to stack, which means I call the class here, and then I will call the function add Rendy again, again, okay, and I will try to print the data items dot buffer. Okay, I'll try to run. Okay, the data already into the stack, right? Okay, so I will try to sorry, as what I said before, stack is last in first out, which means the last element to add it into the stack will be the first element who remove. As let me prove maybe items remove, and then I will print again items buffer. Okay, let's run again. I'll clear here first. Okay, so as you can see, the last element who into the stack will be the first element who removed from the stack, right? 18.9 now is none in the queue. The last element who entered the stack will be the first element who out into from the stack. That's it. That is exactly how stack data structure looks like. Okay. The last one is linked list data structure. I will try to make example of linked list in Python. So first, I will make class for node for have function or method init self and data parameter here, and then we assign self dot data equal to data, and then self dot next equal to none. Okay, and then I will make class for linked list, and then make the init self self dot self dot head equal to none. Okay. So first I will assign a value and then connect the nodes and then print the linked list. Okay. First I will make new variable here known as linked list equal to linked list, which means I make variable here and then call the class linked list here. Okay, and then now is assign a value linked list dot head equal to node, and then I will give my name as a value, and then the second equal to node 80 maybe, and then we will make one more node 30.32. Okay, and then now connect the nodes. I will call linked list dot head, and I will connect the this data. I will connect into this data. Linked list dot head dot next, called next here, and then second, and then the second data I will connect to the third data. Next, third, right? As you can see here, which means in the connect dot nodes, I called linked list head and then code dot next here, which means after this data will be this data. After Elang data will be 80 data, and then the second also. And last, I will print the data. I will check first why linked list dot head not equal to none, which means if the linked list is not none, I will print the data. Linked list dot head dot data. For that, I will assign this variable equal to linked list dot head dot next. Exactly. I will try to run. That's it. Exactly. Now is all working. Okay, that's all from me. I hope you enjoy of that video. So thank you for watching this video. Thank you so much.